Okay, this is 1.5 homework, part 2. And here are a few extra problems that we didn't get to last time. On 7, 8, and 9, here were the instructions. Find the discriminant. You remember how to do the discriminant? It's just the part underneath the radical. B squared minus 4ac. Here's the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So just the b squared minus 4ac is the discriminant. So this says find the discriminant. So we're doing b squared minus 4ac. On this problem, what's a?
1.
And b, 6, and c is 9. So if we do b squared minus 4ac, we're doing 6 squared minus 4 times 1 times 9, or 36, plus or minus?
Minus.
One negative sign makes it minus, and then 36 minus 36, 0 is the discriminant. And then last time we said a discriminant of 0 tells you the solutions are not going to have any i's in them. There is a square root of 0, it's just 0. When you get a discriminant of 0, that's the one and only time when you're only going to have one solution. It won't have any i's, so that'll make it real. The square root of 0 is just 0, so the radical goes away. 1, real, rational, and what's the other thing about a discriminant of 0? Double root.
Yeah.
So 1 real, rational, double root. Now, if I ask you to do one more thing on this and actually solve it and tell me what the solution is, if I were going to solve this the fastest way I could, I would recognize, hey, this is a perfect square trinomial, x times x, 3 times 3. It will factor to be x plus 3 squared. Or I could write it as x plus 3 times x plus 3. And so I've got the zero product property going on. And the only way I can multiply and get an answer of 0 is one of them has to be 0. So x plus 3 equals 0. Or x plus 3 equals 0. And you see that we said the same thing twice. We get x equals negative 3 twice. That's why we say we have a double root. Okay? On number 8, if we're going to calculate the discriminant, because the discriminant lets us predict ahead of time what kind of solutions will we get. Like these were nice. They didn't have any i's in them. They didn't have any radicals in them. So on this one, a is 2, and b is negative 7, and c is negative 4. So if we calculate b squared minus 4ac, then negative 7 squared minus 4 times 2 times negative 4, that makes it 49, because a negative 7 times a negative 7, positive 49. Is it plus or minus?
Plus.
Yep, 2 negative signs makes it plus. 4 times 2 is 8. 8 times 4 is 32. So 49 plus 32, we end up with 81. So the discriminant is 81. What do you notice that's special about 81?
It's the square root.
It's a perfect square, so that when you take the square root of 81,
It's 9.
it's 9. So this problem, if you use the quadratic formula, it's not going to have any radicals left in it. Because this is positive, it won't have any i's.
So it's real.
Because it's a perfect, yes, so, and the only time there's just one solution is when it's a double root. There are really 2 solutions, but it's the same solution twice. Because all quadratic equations have 2 solutions. But sometimes we have one double root. Otherwise, we have 2. In this case, real. What else? No radical means rational roots. Now, if we took this one step further, and we were going to solve it, this is not real easy to solve by factoring. And since we've already got part of the quadratic formula, I might just use it. I might just say, okay, if I want to really solve this, x is equal to negative b, so negative of negative 7 makes it positive 7, plus or minus the square root of, we already did b squared minus 4ac, so square root of 81, all over 2a, all over 2 times 2. That means it's 7 plus or minus, oh,
9.
yep, 7 plus or minus 9, all over 4. Should we leave an answer that looks like that?
No.
So you gotta think, okay, I have 7 plus 9, that's 16 divided by 4. So one of the answers is 4, and the other one, 7 minus 9, negative 2 divided by 4. So negative 2 over 4 is negative 1/2. Do you agree with what we decided? Are these solutions real? Yep, no eyes. Are they rational? Yes, no radicals are left. So the discriminant really did predict for us what kind of solutions we were going to get. Here's one more. On number 9, if we calculate the discriminant, we're doing b squared minus 4ac. And in this case, a is 3, and b is negative 2, and c is 4. And so b squared minus 4ac means negative 2 squared minus 4 times a is 3 and c is 4. Negative 2 times negative 2, we got positive 4. Is it 4 plus or 4 minus?
Minus.
Because only one negative sign, so 4 minus. 4 times 3 is 12. 12 times 4 is 48. So 4 minus 48, we get negative 44. What does this discriminant tell us?
2 complex roots.
It's negative. It's going to be a negative number under the radical. That means because it's negative, we got 2 complex roots. So the discriminant helps us figure out the nature of the roots. That means how many are we going to have and what kind are they going to be. And if we went ahead and solved this one, I would probably say, let's just use the quadratic formula because we're part of the way finished. So that means x will equal negative of negative 2, positive 2, plus or minus the square root of, we've already done b squared minus 4ac, so square root of negative 44, all over 2a, all over 2 times 3. We got to decide if this is going to reduce. Square root of negative 44. That's going to be square root of negative 1 times square root of positive 44. Can we take anything out of that? 2 times 22 and 2 times 11. So these are all prime. That means we can take out a 2, square roots of 11. That means x equals 2 plus or minus I times 2 times square root of 11. I'll call it 2i square roots of 11 all over 6. I'm glad we decided to do this one because here's my question now. Can I do any more than to reduce this?
No.
You can't just cancel a 2 over 6. You can't reduce terms. But is there a factor that's common to all of these?
2.
Take out a 2. If you take out a 2, then 2 times 1 gets us back to 2. And 2 times I square roots of 11 gets us back to 2i square roots of 11. Makes sense? And instead of 6, I'm going to call it 2 times 3. And then these are factors, and we can cancel factors. Does that make sense? 2 is multiplied on the top, 2 is multiplied on the bottom. We can cancel when we're multiplying. So when we simplify this, it's really x equals 1 plus or minus just 1i square roots of 11 all over 3.
Yeah.
Okay. Then there were a couple of problems on your homework that I wanted us to look at on your part 2 assignment. Let's do 105. So those were from the notes, but these problems are off of the homework.
Are we not doing the ones in the 70s?
Oh yeah, I think you kind of wanted to do that one. So on let's do 72. This is one where we have 3x squared equals 6x minus 1. This is one we're solving by using the quadratic formula. The deal on using the quadratic formula, just like factoring, you've got to make it equal 0 first. So I would keep this one positive, and I would subtract 6x and add 1 on both sides. So I have 0 on the right side. 3x squared minus 6x plus 1 equals 0. So that means A equals 3, and B is negative 6, and C equals 1. So x is equal to negative b. Negative of negative 6 is positive 6. Plus or minus the square root of b squared minus 4ac. You remember the quadratic formula. So b squared, that means negative 6 squared, minus 4 times a is 3, and c is 1, all over 2a, all over 2 times 3. Then we got to decide if we can reduce this. So that means 6 plus or minus the square root of, the first number is always positive, negative 6 times negative 6 is 36. Is it plus or minus?
Minus.
Only one negative sign. Odd number of negatives is negative. So minus 4 times 3 times 1, we got 12, all over 6. That means x equals 6 plus or minus the square root of 24, all over 6. Now, here's the deal. Can I cancel 6 over 6?
No.
Cannot, because those are terms we're adding on the top. Is there any way I could reduce this? Well, maybe. I gotta see, what about the square root of 24? That's 2 times 12, and then 2 times 6, and then 2 times 3. So we get to take out a 2. So the square root of 24, I can replace with 2, help me, square root of,
6.
yeah. So x equals 6 plus or minus 2 times the square root of 6, all over 6. I cannot cancel the 6's because those are terms. But is there any common factor? So that means I can factor out a 2. If we factor out a 2, then I have to multiply 2 times 3 to get back to the 6. And 2 times the square root of 6. And instead of 6 on the bottom, we're going to think of it as 2 times 3. 2's, the 2's are factors, and we can cancel factors. Can't cancel terms. So we're stuck with this, 3 plus or minus the square root of 6, all over 3. Can't cancel those 3's because they're being added and subtracted on the top. Those are terms. Does that help? Okay, let's talk about 105. Can you still see right here? If I put it up here,
Yes, just don't go too far over to the side.
can you see that right here?
No.
Okay, let me erase. So this is 105. And it says, on this one, you get to pick the method of your choice. So 1 over x plus 1 over x plus 2 equals 1 over 3. It looks ugly to us because it's got fractions in it. But early in this chapter, we learned a magic trick that will make the fractions disappear. You remember what it is? Multiply every single term by the least common denominator. So we got to figure out on this one, what's the common denominator? Well, every denominator I have needs to be factored, but they're already factored. I'm going to think of this as 1 times x plus 2, and 1 times x, and 3. So to find the least common denominator, we write down every factor we see, the most number of times we see it in one spot. So I got to write down an x, and a 3, and an x plus 2. I'm not going to worry about the 1. So the least common denominator, I have to have a 3. I'm going to write 3 first. 3, and x plus 2. So every fraction all the way across on both sides gets multiplied by this common denominator. 1 over x gets multiplied by 3 times x plus 2. And if it looks better, gets multiplied by 3 and x plus 2. And we can put it over 1 if it looks better. And 1 over 3 gets multiplied by 3 times x plus 2. And so that we know it's on top, we'll put it over 1. Now, you see what that did for us? I got an x on top and an x on bottom. So that means those cancel out. So I just have 1 times 3, or really just 3, that I gotta distribute. And that makes it 3x plus 6. And on this one, x plus 2's go away. So I've got, just have to multiply 1 times 3 times x, so that's just gonna give me plus 3x. And on the other side, I got a 3 on the top and a 3 on the bottom. So now all I have is 1 times x, or just x, that we need to distribute to get x squared plus 2x. Are you okay?
And now we like, oh.
And doesn't that look a whole lot better than what we started with? It's a quadratic equation. You know how I know? I see an x squared. So combine what we have. On the left side, we've got 6x plus 6 equals x squared plus 2x. And then I need, if I'm going to solve a quadratic equation, I really need it to be in a good standard form. Let's make it equal 0. So if we subtract 6x from both sides, and if we subtract 6 from both sides, because I want to keep x squared, the first term, I want it to be positive. So now I have 0 equals x squared minus 4x minus 6. We started out with this ugly rational equation, rational means fractional, and we multiplied every single term all the way across on both sides by the common denominator, and now we got this, a quadratic equation. So we've got these choices on solving a quadratic equation. We can factor it. We can take square roots. We can use quadratic formula. Could even complete the square, but we probably don't want to do that. What do you think? Does it look like it factors? Does anything multiply to be -6 and add to be -4? I would say no. So then, if we want to solve it, probably our best option is quadratic formula. That means a equals 1, and b equals -4, and c equals -6. So here we go. X is equal to -b. Negative of -4 is +4, plus or minus the square root of b squared. That means -4 squared, -4 times -4. This number is always positive. 16 minus 4ac, so 4 times 1 times -6, all over 2a, all over 2 times 1. That makes it 4 plus or minus the square root of 16 plus or 16 minus?
16 plus.
Because we got 2 negatives. 16 plus 24 all over 2. So that makes it 4 plus or minus the square root of 40 all over 2. Are we okay?
Yeah, I'm just taking forever.
And then we gotta decide if it'll reduce. So for the square root of 40, that's 2 times 20, and then 2 times 10, and then 2 times 5. So we know we can take out a 2. 4 plus or minus 2 times the square root of 10, all over 2. Would it be okay if I cancel those 2's? No, because they're terms, I'm adding on top. Is there any way I can have factors that belong to this?
Divide by 2.
Or factor out a 2?
Yeah.
If we factor out a 2 and write it as a multiplier, 2 times 2 gets me back to 4. Plus or minus 2 times just 1 square root of 10 will get me back to 2 square roots of 10. And then on the bottom I have this 2, and now I can reduce. Does that make it better? Maybe? Okay, let's do one more, and then we're done. So let's do one 107. Let's see, on 107 we have 2x over x minus 3 plus 6 over x plus 3 equals negative 28 over x squared minus 9. Notice that this negative is out in the front. When, for a fraction, the negative can be on the top or on the bottom or out in front. But when it's out in front, it doesn't go in both places. So it might be easiest if we think of that negative as going with the top. We need to make that, it's a rational equation. And so we have this strategy to solve rational equations. We want to make the fractions go away. Magic trick. Find the common denominator, then multiply every term by the common denominator. So that means I got a factor. Well, this could just be 1 times x minus 3 and 1 times x plus 3. But this is a difference of 2 squares. Tell me, how does it factor?
X plus 3, x minus 3.
Yes. So the least common denominator, I have to write down every factor I see that's different. The most number of times I see it in one spot. I see x minus 3 once here, not at all here, once here. I write it once, because I don't ever see it more than one time in any of the original fractions. I have x plus 3 once here and once here, but it doesn't ever happen more than one time in any one place, so I write it once. So the next thing is, don't get a common denominator, but instead multiply every term. So we got 2x over x minus 3 has to get multiplied by x minus 3 times x plus 3 plus 6 over x plus 3 has to get multiplied by x minus 3 times x plus 3 equals negative 28. I'm putting the negative on the top, and I'm going to write the bottom as its factored version. So negative 28 over x plus 3 and x minus 3 has to get multiplied by another x plus 3 and x minus 3. And if it makes you happy, remember these are over 1. And then we got a lot of canceling that can happen. So x minus 3 over x minus 3 means really I have a 2x to distribute. So 2x squared plus 6x, no more fractions there, magic. Then x plus 3 on top and on bottom. Look for the sign in front, because if this happened to be a negative, it would have to be distributed as a negative 6. It's not. So we have plus 6x, positive times negative is negative 18, equals, on the other side, an x plus 3 will cancel, and an x minus 3 over x minus 3 will cancel. So all we have left is negative 28. That made it look a lot better, right? It's easier to work with. It's quadratic. We just have to clean it up a little bit because we want to make it equal 0. So that means 2x squared, combine these, plus 12x, and then if I make it equal 0, I might as well go ahead and add 28 to both sides. So negative 18, positive 28, that's going to make it plus 10 equals 0. I would do one more thing to make this easier. I would notice that all of these numbers are even, so I can kind of reduce this equation. I can balance it out. It will mean the same thing if I divide everything all the way across on both sides by 2. And now I'm solving x squared plus 6x plus 5 equals just 0. So I get to pick, do I want to solve by factoring or square roots or completing the square root? We said that's not going to be our option. But factoring or square roots or quadratic formula, I would always try to factor it first. Does it factor? Does anything multiply to be 5? That will add to be 6.
5 and 1.
This factor those two things multiply to equal 0, then that means either x plus 1 equals 0, or x equals -1 is the solution, a solution, or x plus 5 equals 0, so x equals -5 is a solution.
Because you like factored it or whatever, shouldn't you like put a 2 out in front?
I can, but if I factored a 2 out of it instead of dividing everything by 2, I would still have this. So I would have 2 times, and then I would have 3 things that multiply to be 0. Would 2 ever be able to turn into 0? Then we just ignore it. But I really didn't factor out a 2, I could have.
But
I
that's what
divided.
you did.
I divided everything by 2, yeah. And since I knew that 2 was not gonna be, 2 can't be 0, then I just don't worry about it.
Okay.
Are we good?